Table of Contents. Preface. Unit 1, Mechanics. Chapter 1. Units and Measurement. 1.1. The Scope and Scale of Physics. 1.2. Units and Standards. 1.3. Unit Conversion. 1.4. Dimensional Analysis. 1.5. Estimates and Fermi Calculations. 1.6. Significant Figures. 1.7. Solving Problems in Physics. Chapter 2. Vectors. 2.1. Scalars and Vectors. 2.2. Coordinate Systems and Components of a Vector. 2.3. Algebra of Vectors. 2.4. Products of Vectors. Chapter 3. Motion along a straight line. 3.1. Position, displacement, and average velocity. 3.2. Instantaneous velocity and speed. 3.3. Average and instantaneous acceleration. 3.4. Motion with constant acceleration. 3.5. Free fall. 3.6. Finding velocity and displacement from acceleration. Chapter 4. Motion in 2 and 3 dimensions. 4.1. Displacement and velocity vectors. 4.2. Acceleration vector. 4.3. Projectile motion. 4.4. Uniform circular motion. 4.5. Relative motion in 1 and 2 dimensions. Chapter 5. Newton's laws of motion. 5.1. Forces. 5.2. Newton's first law. 5.3. Newton's second law. 5.4. Mass and weight. 5.5. Newton's third law. 5.6. Common forces. 5.7. Drawing free body diagrams. Chapter 6. Applications of Newton's laws. 6.1. Solving problems with Newton's laws. 6.2. Friction. 6.3. Centripetal force. 6.4. Drag force and terminal speed. Chapter 7. Work and kinetic energy. 7.1. Work. 7.2. Kinetic energy. 7.3. Work energy theorem. 7.4. Power. Chapter 8. Potential energy and conservation of energy. 8.1. Potential energy of a system. 8.2. Conservative and non-conservative forces. 8.3. Conservation of energy. 8.4. Potential energy diagrams and stability. 8.5. Sources of energy. Chapter 9. Linear momentum and collisions. 9.1. Linear momentum. 9.2. Impulse and collisions. 9.3. Conservation of linear momentum. 9.4. Types of collisions. 9.5. Collisions in multiple dimensions. 9.6. Center of mass. 9.7. Rocket propulsion. Chapter 10. Fixed axis rotation. 10.1. Rotational variables. 10.2. Rotation with constant angular acceleration. 10.3. Relating angular and translational quantities. 10.4. Moment of inertia and rotational kinetic energy. 10.5. Calculating moments of inertia. 10.6. Torque. 10.7. Newton's second law for rotation. 10.8. Work and power for rotational motion. Chapter 11. Angular momentum. 11.1. Rolling motion. 11.2. Angular momentum. 11.3. Conservation of angular momentum. 11.4. Precession of a gyroscope. Chapter 12. Static equilibrium and elasticity. 12.1. Conditions for static equilibrium. 12.2. Examples of static equilibrium. 12.3. Stress, strain, and elastic modulus. 12.4. Elasticity and plasticity. Chapter 13. Gravitation. 13.1. Newton's law of universal gravitation. 13.2. Gravitation near Earth's surface. 13.3. Gravitational potential energy and total energy. 13.4. Satellite orbits and energy. 13.5. Kepler's laws of planetary motion. 13.6. Tidal forces. 13.7. Einstein's theory of gravity. Chapter 14. Fluid mechanics. 14.1. Fluids, density, and pressure. 14.2. Measuring pressure. 14.3. Pascal's principle and hydraulics. 14.4. Archimedes' principle and buoyancy. 14.5. Fluid dynamics. 14.6. Bernoulli's equation. 14.7. Viscosity and turbulence. Unit 2. Waves and acoustics. Chapter 15. Oscillations. 15.1. Simple harmonic motion. 15.2. Energy in simple harmonic motion. 15.3. Comparing simple harmonic motion and circular motion. 15.4. Pendulums. 15.5. Damped oscillations. 15.6. Forced oscillations. Chapter 16. Waves. 16.1. Traveling waves. 16.2. Mathematics of waves. 16.3. Wave speed on a stretched string. 16.4. Energy and power of a wave. 16.5. Interference of waves. 16.6. Standing waves and resonance. Chapter 17. Sound. 17.1. Sound waves. 17.2. Speed of sound. 17.3. Sound intensity. 17.4. Normal modes of a standing sound wave. 17.5. Sources of musical sound. 17.6. Beats. 17.7. The Doppler effect. 17.8. Shock waves. Appendix A. Units. Appendix B. Conversion factors. Appendix C. Fundamental constants. Appendix D. Astronomical data. Appendix E. Mathematical formulas. Appendix F. Chemistry. Appendix G. The Greek alphabet. Index.